Yeah, my name is Lucas Bruder, co-founder and CEO at Jito Labs. I here to walk through the Jito restaking and vault code. Was one of the main engineers behind Jito restaking and the vault program. So here to kind of go through it and talk about the features and what it's capable of, and probably answer some questions at the end. So yeah, when you go to the repo, it's github.com/Jito dash foundation slash restaking. You can view the README, goes through a lot of the details on how to work with the repo. You can also go to docs.restaking.jito.wtf. Let me actually share my entire screen here. Cool. So yeah, you can go through all the documentation here. Docs. There's a lot of terminology about the program and everything. The two programs, how they kind of interface together, all the accounts in the programs, and the theory of operation. So I'll kind of start here. Jito restaking, it's a multi-asset staking protocol for node consensus networks. Node consensus network, you've probably heard of this in a few other ecosystems. Some people call them networks. Some people call them AVSs, actively validated services. They're all kind of generally the same thing. It's essentially a network of operators that are running some software, coming to consensus on some values. And so this protocol was built to allow and support these networks on Solana. So, breaking this down a little bit, multi-asset, it works with any SPL token. So you can use, Wrap Sol, Jito Sol, and any LSTs, governance tokens, LP tokens, anything that's a SPL token, it supports. And so essentially the way it works is you can program is basically responsible for creating wrapped assets. We call them vault receipt tokens, and they essentially are a pro rata share of the assets deposited into a vault. And a vault, it does a few things. It's responsible for minting and burning vault receipt tokens. There's a few fees associated with vaults as well. So you can have deposit fees, withdrawal fees. There's also like a performance fee that the vault manager can take. There's several administrative controls as well that can be delegated to different parties. The vault's also responsible for delegation. So there will be, if you're running a vault and you have assets staked to it, you need to delegate those assets to a variety of operators. And then this isn't in the current version, but in future versions, there may be slashing added as well. So there's a few kind of stages to a vault. There's initializing it. You can deposit assets into it. You can add and remove NCNs. So I'll get into this in a bit, but there's kind of a tri-party agreement that needs to take place for assets to be considered staked to an operator that's running on an NCN. So the vault can basically opt in and out of the networks that those assets are staked to. Can add and remove operators, delegations, and so on. There's also the restaking program. You can think of the restaking program as a registry for NCNs, operators, and it's kind of it's a registry of relationships. So people can register NCNs. If you're an operator, you register through this program. And then there's these a few pieces of state here that kind of controls the opt-in and opt-out. So NCNs, let me see if I can find this. Okay, here we go. So this is kind of showing the tri-party agreement that I was talking about earlier. So you have an operator, an NCN, and a vault. These are the three main parties involved with the vault and restaking program. So NCNs have to opt into operators that can run the software on their network. And this allows a lot of flexibility. So NCNs can potentially, any operator they see that's registered, they could add. You could just have like some automation around that where you're looking for new operators. You can have DAO controlled operators as well. So if you have a DAO or a multi-sig or something like that, you can delegate the addition and removal of operators to your operator set. It goes the other way too for operators. So operators can opt into and opt out of NCNs. If you want to start running the software for a network, you can opt in. And then if you're shutting down for some reason or you don't want to run that software anymore, then you can opt out and you won't be applied to the validator set. Same way goes for vaults as well. So NCNs need to signify support for a vault, and vaults need to do the same. So if you're building an NCN, maybe you just want to support assets that aren't super volatile, that have a lot of cheap security. LSTs are a great use case for this. So maybe you just support vaults that are based on LSTs. And then there will likely be NCNs that have their own governance tokens or utility tokens. So maybe they want to support those as well, and they don't want to support anything else. So this is kind of the mechanism that they do that. So vaults can say, hey, I want this, or NCNs can say, hey, I want to have this vault staked to me, or I don't want this vault to stake to me. And then same for the operator and vault relationship. Let's see what's next. Yeah, so there's a few main parties in the restaking program. A few main accounts. There's the NCN account. There's a few administrative roles in there that we'll dive into a bit later. There's the operator one as well, so you can have operator fees applied there. You can add and remove support for vaults and NCNs. Um, and then there's all the relationships that I was showing you in the previous slide. So you have NCN operator states that kind of tracks the NCN opting into and out of a operator. There's the NCN vault ticket, which is basically the NCN saying they want to support a vault or not. And then you have operator vault ticket and so on. And then slashing isn't currently enabled, but may be enabled in the future, depending on the Jito DAO approving the adoption of slashing. So there's some state track there as well. Um, and the vault has similar. So the vault has a vault account, you have your vault NCN ticket, you have the operator delegation, which is essentially the vault opts into an operator and then it can stake assets on there. And there's the slasher tickets as well. And then there's also the withdrawal tickets. So when stakers withdraw from the vault, creates a withdrawal ticket that takes one full Solana epoch to mature, and then the user can withdraw. So yeah, I think that's a good start. You can see the programs and versions deployed on the different networks here as well, but I think it makes sense to dive into some code now. So I think the best way to dive into Solana programs is looking at starting at the instructions. Really gives you a good idea of like what the program is capable of. And this program is written in, I guess you could say, Solana native. It's not Anchor. So It uses the kind of traditional instruction format compared to Anchor. That's a little more complicated. So, yeah, you can see here uh, we have our role instructions. This is all Shank here. So Shank will auto generate you client code and generate IDLs for you. So I think the key instructions to look at and the ones that most people are using would be initialize vault, initializing vault operator delegations. You have all your relationships that you are initializing as well. So you can warm up and cool down all the different relationships here. The one that stakers will interact with are Mint2. So you can deposit a number of tokens into the vault and it will mint you basically a pro rata share of those. You can handle any fees. And then when users want to withdraw, they can essentially take the vault receipt token, stick it back into the vault, and those tokens actually sit in a withdrawal ticket. That withdrawal ticket matures, and then after one full Solana epoch, it will allow you to withdraw the amount that you or the pro rata amount that you should get back. Um, there's a few other configuration things that you can do with the vault. So you can set the deposit capacity. You can set fees as well. So there's a few different fees that vault operators or vault managers can apply. All of these are in BIPs. So you can apply a deposit fee, a withdrawal fee, and then the reward fee, which is essentially the reward fee is when assets get one side deposited into the vault, you can update the vault balance and take a fee on the difference. Um, there's a program wide feed as well. So the Jito DAO controls the program fee, currently set to, I think it's 100 bips right now. Um, Vaults can also pause operations and resume them. And what else? There's a few admin functionality in here as too. So there's the main admin, and then there's some secondary admins. So the admin flexibility of the vaults is it's very flexible. So you can delegate the delegation to other parties. You can delegate adding and removing operators. You can delegate who can control the capacity of the vault. You can change where the fees go. There's a bunch of uh, parameters that you can adjust there. The Vault Delegation Manager can add delegations and cool down delegations. You can update the vault bounce. So this will kind of adjust the pro rata share of the it'll adjust the essentially price of the vault relative to the token mint that's deposited, and we'll collect the reward fee. And then there's some update instructions as well that I'll get into in a bit. And then, of course, a vault will create a token mint, so you can set the token mint metadata and update it as well. Cool. So now I'll dive into the program. This is the entry point for the Vault program. So I'll just go through a few of like the common instructions so people can kind of get a feel of how this program works and how people interact with it. I'm gonna take a drink of water real quick. All right. So yeah, let's go into initialize vault. If you're creating a vault, you'll call this instruction. You can see the parameters that you supply here. Cool. So yeah, walking kind of section by section, um, we will basically try to read all the accounts in from this accounts iterator. And this is pretty similar to the next account infos that you see in some Solana programs. I think it's a little cleaner. And essentially, we just go account by account, kind of loading it, parsing it, making sure it's correct. So you can see here that we're loading some accounts here. You can see it's pretty obvious, like what's a signer, what's a token mint. I'll click into this. System accounts are essentially empty accounts that are just created. And then, you have your signers as well, where you can check to see if the account's a signer. And then, yeah, the rest is basically you derive the vault. You derive the vault's program derived address. You check to make sure it's correct. You check to make sure the fees are correct. And then essentially it will create the account for the token mint and call initialize mint on it. And then you'll create the vault account and then you'll initialize it. And there's some state tracking as well. So when you initialize the vault, it will increment this global kind of counter in the config as well. Yeah, let's see what else. I guess this program uses bytemuck, so it's all zero copy. So when you modify these accounts, you're working on like this raw byte array. And so there's no like saving or anything. It just works magically. So yeah, this is a very common instruction. If you want to create a vault, you'll initialize that here. And then let's see what else. Let me go to another one will be mint2. Okay. So yeah, minting, it's a process of when a staker will deposit assets into the vault and receive a vault receipt token that represents their pro rata share. I guess one thing I skimmed over earlier is when you are every vault only supports a single token mint. So you can see here, we call it the supported token or the supported mint. And so vaults will only support a single SPL token. If you want to create a vault that has multiple tokens, like maybe you want to make one that supports several different LSTs on Solana, or maybe there's one where it's several different wrapped versions of Bitcoin, you will need to build a wrapper on top of the vault program and kind of like normalize those assets. And then you can use the normalized version as the supported mint. So when you're minting, calling mint2, you're essentially the user is they're depositing the assets into the vault, and then they are getting minted a pro rata share of the vault token. And then there's also a fee applied as well to the vault if there's a deposit fee. So yeah, kind of the same layout here. You can see that we're parsing a bunch of accounts, loading all the data. We like to go kind of one by one when we load the accounts, so it's a little easier to follow on what's going on. So you can see we'll load the config, load the vault, and then we'll load a bunch of other accounts like token mints, associated token accounts. We'll check some of the privileges and relationships as well. So you're making sure that the mint passed in is the correct one, making sure that the vault doesn't need to be updated, and so on. Something else is that you'll see this check for mint burn admin. This will essentially let you, if you want to permission your minting and burning to require a signer, you can do that through this program, through the vault configuration. Some areas where this might be useful is going back to the normalized token thing that I was mentioning earlier. If you want to kind of force people to go through a different program, then you can do that. In the mint burn admin can be a PDA owned by the other program. Um, if you want to gate it to, like, you have some key signing infrastructure, or you want to gate it to certain depositors for like regulatory reasons or whatever it is, you can have basically some key signing infrastructure, or you have a hot wallet that signs it as well. So yeah, bunch of like validation checks, and then this is where the actual minting takes place. So yeah, you check your deposit capacity, you calculate um, how many of the VRT should be minted, and then you kind of save the VRT supply and the tokens deposited, and then you run your transfers where you take the users or the stakers tokens, you transfer them to the vault token account, and then you can see that the VRT mint is minting tokens to the depositor as well. Um, so yeah, it's a common one. Going the other way, there's also in queue withdraw. So in queue withdrawal, basically, you can think of it like cooling down a stake account on Solana, and you need this to happen so that basically stake can't immediately leave the vault or leave an operator. If that were the case, then someone could potentially front run a slashing event or some other event where the vault's impacted. So when you enqueue a withdraw, the funds kind of sit in an account that the user can claim later, and it allows those assets to continue to contribute to security, but also be slashable. So, similar layout here. You'll see we load the config, load the vault, we run some validation checks, we create the vault staker withdraw ticket, and then we'll transfer the user's tokens to the vault staker withdraw ticket, where they kind of sit and wait for it to mature. You'll notice there's also a mint burn admin here. If you want it, you don't need to use it. Trying to think what else. Something else I'll get into in a bit is basically the vaults will set aside assets for you for the vault. The vault has bookkeeping to support assets that need to be unstaked to fulfill this request. So there's some internal bookkeeping inside the vault where that happens as well. Cool. So you have a withdraw ticket, you waited for it to mature. Now you can call burn withdraw ticket. That will load all the accounts per usual. You want to check to make sure that it's the staker is the one that's kind of withdrawing the vault ticket. And then yeah, basically the vault receipt token will be burned, and the user will get back their tokens here. So you can see if there's a vault fee. So if the vault has a withdrawal amount or withdrawal fee that it's applying, that will go to the vault. There's also a program fee, which is controlled by Jito DAO. So the DAO gets I think 100 bips from the program fee, and then the tokens are burned. The vault staker withdraw ticket token account is closed, and then the vault will transfer the tokens from its vault token account back to the user. Cool. There's a bunch of other stuff in here too, like initializing the vault NCN ticket. I'll go into that, kind of what that looks like. If you understand the vault NCN ticket, you'll kind of understand the other tickets and state trackers as well. The vault NCN ticket is another account on Solana. So you have your vault, the NCN. There's an index in here as well. So when you have a lot of accounts on Solana, it can be hard to deterministically iterate through all of them and know how many there are. So this index combined with um, the vault keeping track of how many tickets there are basically lets you deterministically order or iterate through all of the vault and CN tickets. Um, so yeah, there's the index, there's the state, which I'll get into in a second, and then some accessor and loading methods as well. The slot toggle, you'll see that used a lot. Essentially, this is a way to keep track of what's activating, what's activated, and what's cooling down as well. So in you can see that there's some transition methods here when you activate and deactivate. For instance, if your current state is inactive, that's the only time that you can transition to warming up and then deactivate as well. You need to be active to be doing that. And then there's some essentially methods here to determine what state you're in. This is nice because you don't need to crank a bunch of programs to update the state. It essentially uses the slot added and slot removed to track what the vault or the ticket state is. So you'll see that used a lot in the ticket and state methods. So yeah, that's the vault and CN ticket. There's a few other ones. Um, I won't get into slashing. That's not going to be active. I guess the other one is the vault operator delegation. So the vault operator delegation account, it stores information about the delegation state of the vault to a specific operator. And so you need this is a separate account on Solana. So you have the vault operator delegation state, which I'll get into in a second. The last update slot. This essentially keeps track of ensures the vault and the operator delegations are up to date. So you need to run an operation once an epoch to make sure everything's up to date. You have the index here as well, which I talked about previously. Essentially makes iterating through things deterministic, and then some reserve state. So yeah, when you are working with the vault, there's a few things that you can do, or the vault operator delegation. There's a few things that you can do. You can initialize it, which this instruction does here. So there's some count loading, count creation, and then this state tracking as well. You can add delegation to it. So you can see that we're loading the vault operator delegation, and then we are delegating assets to it. And then what else? Oh yeah, you need to when you're delegating assets, you need to make sure that you have vaults available to delegate or assets available to delegate. So there's some logic in the vault that essentially ensures that you have assets to delegate, and then also you need to when you're creating the in-queue withdraw tickets that I mentioned earlier, there's funds that need to be set aside to ensure that when a user's withdraw ticket matures, that they have enough funds to fulfill that. The vault has enough funds. So it will avoid over delegating assets by looking at the total tokens deposited, how many assets are reserved for withdraw, and doing some math to essentially have a global delegation state that keeps track of the delegation for all operators within the vault. You can also cool down delegations. So This essentially lets you, like, if you want to move assets from one operator to another, you can enter them into cooldown. They'll need one full epoch to cool down, and then you will essentially have assets to delegate. And so you can run add delegation on a different operator as well. And then, yeah, let's get into, I'll get into the other kind of important part here that will become more important as more NCNs join and vaults start delegating to them. That is the that's a vault update state tracking. So let me dive into that real quick after I take a drink of water. Okay. So every epoch, the vault needs to iterate through all of the operator delegations and retally where stake is at so that it knows how much stake's in the vault, how much is cooling down. It needs to ensure that this is basically like the worst case scenario for if the another valuable piece of this too is that if the someone is cooling down assets, there's kind of two ways that the vault can force them into cooldown so that they can be the withdrawal ticket can be fulfilled. One is by using the cooldown delegation that I just talked about. So let's say vault has 100 assets or 100 units of some asset. Someone wants to cool down or include a withdraw that wants to pull 10 units out of the vault that are delegated. There's kind of two ways that can happen. One is that the vault manager, the delegation manager, can essentially keep refreshing the count state. They'll say, "Oh, there's 10 units that need to be withdrawn. This. I think that this operator is the right one to withdraw them from, so I'm going to manually withdraw that." That's one way of doing it. The vault update state tracker is kind of another way to do it, and it's kind of the um, essentially just runs a process where it will iterate through all of the vault operator delegations. It will kind of crank some state, and then it will basically aggregate that state and copy it into the vault. And then it also ensures that the vault has enough assets to fulfill withdrawal request. You don't end up in a state where like the vault's kind of dead, the delegation manager isn't running it. There's a lot of things in queued that can't get they can't get cooled down, and then there's kind of like fun stuck. So this is kind of like the worst case scenario backup to do that. So essentially what happens is it will calculate the assets that need to be unstaked, and it will save that into the vault update state tracker. And then what you need to do is you'll need to call crank vault update state tracker, looping through every vault. And you'll see here that we're using the operator delegation index and the operator count. It's kind of why I was what I was pointing to earlier, where the vault knows how many operators are in the set, so you can ensure that you're looping through every account here deterministically and in order. So yeah, it'll make sure you're on the right index. You can it'll withdraw anything that needs to be withdrawn from the vault or from the operator, and then it keeps track of what's withdrawn in the vault state. So yeah, it'll do that. You'll go through that for every operator delegation. And then there's a close update state tracker. So that will essentially, you've accumulated a bunch of state into this update state tracker for the given epoch. So then you will essentially copy any accumulated state, like the delegation state, back into the vault. And then you'll set the last full epoch, and then you'll kind of help cool down some state within within the vault as well. And then that account will be closed. So yeah, it's kind of how the vault works at a high level. There's some other methods here. You can, let me see here. You can delegate token accounts owned by the vault so that kind of, if there's a fee account or the vault gets airdrop some tokens, you can run this delegation method to delegate it to a ledger or something like that. So the ledger can pull assets out of there. Yeah, there's all these admins as well. So when you're running any instructions related to these kind of roles, it will check to make sure the admin is correct. You can change the admin as you please. If you want to, there's kind of this theme of people running vaults outsourcing it to firms that know how to manage risk, maybe like a Gauntlet or something. So, one use case for the secondary admin would say, hey, we want to run this vault, but we want to have Gauntlet control how the assets are delegated, but we don't want them to control anything else. You don't have to give up control of the entire vault. You can just give them the delegation admin. Cool. So let me go through the restaking program real quick. I'm gonna go through this one a little faster. The vault program is the only program that stores user funds. So that's definitely the part of code to look at the closest. And so yeah, the restaking program, you can essentially initialize the NCNs, operators. NCN is a pretty simple account. You have a lot of these admins as well, and then some indexing and state tracking in here. You can initialize the operator as well. So the operator has a few administrative roles with it. There's a voter pub key. So similar to, it kind of mimics Solana's stake account or validator model, where you have a vote account and then there's a voter for it, which is essentially a hot wallet that you can change in case there's compromise or some other reason. And then there's essentially an admin, which will be like a cold wallet controlling the other parts of the vault. And then yeah, you have all these like state trackers. So I was showing you guys this kind of pie chart here. So if you look here, like let's look at the operator NCN. So you have the NCN operator state, and you can essentially initialize this account. And then there's kind of two slot toggles in here. So the NCN opts into the operator, and then the operator can opt into the NCN as well. And then yeah, there's all the warm up things associated with that as well. So you can warm up the NCN can warm up the operator. The operator can warm up the NCN and cool it down. There's some admin functionality in here as well. And then you can set the fees, and you can also, the NCN and operator can delegate token accounts. So if there's an NCN or if there's an operator that gets an airdrop of some token, then they can essentially delegate the token account to a hot wallet, like a ledger, or like a phantom wallet or backpack or whatever it is, and then they can kind of withdraw funds from that as it goes. Cool. So I think I'll stop there. Maybe you want to go through some questions, if there's any, or anything I missed.
No, I think you covered everything.
I guess one thing or two things I can cover real quick. Um, there's a CLI that you can use. So um, let me find the CLI. So yeah, you can use this to interface, write and read to the different programs. So in the restaking program, you can, if you're an operator, you can initialize it and warm things up and cool it down. This isn't completely filled out yet, but it'll be filled out as this kind of ecosystem develops. Same for NCNs as well. So you can initialize NCN, get one, you can list them all. There's also a few vault commands as well. So if you want to create a vault, you can essentially call the vault initialize, the token mint, and some of the other parameters. You can set the metadata and so on through that. There's also a cranker here too. So I was going through the vault update state tracker, and this is essentially a pretty simple cranker. So what it does is it will just constantly refresh the slot, figure out the epoch. The NCN epochs are and restaking and vault epochs are matched to Solana epochs. So essentially, you'll get all the vaults and figure out what vaults need to be updated, and then figure out the operator delegations and where kind of it is in the cranking process, and then it will update the vaults. So this is kind of it'll update every vault. It's permissionless update vaults. So this is kind of just like a public good that people will run to keep everyone's vault updated. And then, yeah, if you want to test things as well, there's some integration test here. So you can see we're using, under the hood, we're using Solana program test. So you can test in kind of, if you can test kind of in two different modes. One is where it runs as essentially a native program, and the way that we would recommend running it is similar to this. So basically, you would build a program to generate the bytecode, and then you tell the program test where the bytecode is, and run. You can run next test or cargo test on it, and that will actually use the program that would be deployed to the network to test. So yeah, there's a bunch of different edge cases and kind of happy paths that are tested here, making sure the vault's initialized okay, trying to put more than 100% fees should fail and things like that. So this is a good place to look for testing different vault features. And it's also, see if we can run it here. It's going to take a bit to compile because I haven't done this in a while.